The Serapeum is associated with the Apis balls because there is some kind of connection with a celestial intelligence and what these underground structures really represent.
Deep beneath the sands of Saqqara, past the crumbling pyramids, lies a tomb that shouldn't exist. There are no gold treasures here, no mummies, just 24 colossal granite boxes, each weighing as much as a Boeing 737. That's tons. They are carved with a precision that defies the Bronze Age, hidden in tunnels so tight that moving them seems impossible. Are these the coffins of gods, or is the Serapium actually the greatest evidence of a lost high-tech civilization? Let's all find out, if we can. The math of the impossible. Let's get one thing straight. These aren't just big boxes. If you were to walk into a high-end machine shop today, the kind that makes precision parts for SpaceX, high-performance jet engines, or medical imaging equipment, you'd find something called a surface plate. It's a massive, heavy block of igneous rock, usually granite, polished so incredibly flat that engineers use it as a true zero reference point to calibrate their most sensitive measuring instruments. It is the gold standard of flatness in modern manufacturing. Now, imagine finding 24 of those gold standards, each weighing as much as a small house, abandoned inside a dark, claustrophobic tunnel from thousands of years ago. That's the reality of the Serapeum. This isn't just neat ancient history, it's an engineering crisis. When mechanical engineer Christopher Dunn stepped into the stifling heat of these tunnels, he brought with him tools that aren't usually found in an archaeologist's kit: a machinist's square and a precision straight edge with a tolerance of 0.0001 of an inch. He wasn't looking for inscriptions or pottery shards. He was looking for the fingerprints of the tools used to create these monoliths. What he found remains one of the most controversial discoveries in the field of experimental archaeology. We're talking about 90-degree internal angles that are so sharp, so crisp, and so mathematically perfect that they defy the logic of hand tool production. If you've ever tried to sand a wooden box or chisel out a corner, you know that tools naturally want to round off the edges. Friction and the human hand do not like sharp corners. In modern stoneworking, carving a sharp internal corner in a material as hard as rose granite, which is packed with abrasive quartz crystals, is a nightmare. Usually, it requires a fixed-point CNC machine or specialized diamond-tipped saws to ensure the corner doesn't blow out or curve. Yet the interior corners of these boxes show no signs of the rounding you'd expect from a human swinging a mallet. They are dead corners, perfectly perpendicular. Then there's the issue of surface flatness, which is where things go from impressive to impossible. Dunn placed his precision straight edge against the interior walls and performed what's known in the trade as a light test. He shone a powerful flashlight behind the edge of the tool. In a normal handmade box, you would see tiny slivers of light leaking through the microscopic gaps where the surface is uneven or wavy. Here, total darkness. The seal between the tool and the stone was so perfect that not a single photon could pass through. Measurements showed that these surfaces are flat to within 0.0002 inches. To give you a mental visual of how insane that is, a single human hair is about 0.002 inches thick. These ancient masons, working in a hole in the ground, were achieving tolerances 10 times thinner than a human hair across surfaces that span 10 to 12 feet in length. Even with modern technology, achieving this over such a large surface area requires massive computer-controlled polishing machines and a climate-controlled environment. Granite expands and contracts with temperature changes. The mere heat from a human body can warp a precision measurement. How did the Egyptians manage this in a humid, dusty tunnel? The mystery deepens when you look at the parallelism. It's one thing to make a wall flat. It's quite another to make the opposing wall perfectly parallel to the first, and then make the floor perfectly perpendicular to both. If you're a modern builder, you know how hard it is to get two walls in a house perfectly parallel using lasers and digital levels. These boxes are essentially 6-sided perfection. The precision is so consistent across multiple containers that it suggests a standardized industrial process. This wasn't a one-off masterpiece, it was a production line of impossibility. Why would anyone need a coffin for a bull to be finished to aerospace standards? Why spend hundreds of thousands of man-hours polishing the inside of a box to a mirror finish if it was just going to be sealed forever? In the world of engineering, you don't overspec a project this much unless the precision is vital to the machine's operation. The sheer level of math involved suggests that the function of these boxes depended entirely on their geometry. If the angles were off by even the width of a hair, whatever they were intended for, whether it was acoustic resonance, chemical containment, or something we haven't even dreamed of yet, might not have worked. We are looking at a level of metrology that our own civilization didn't reach until the Industrial Revolution. But even if you could somehow carve these with a copper chisel, it leads to an even bigger headache. How do you move a 100-ton block through a tunnel where a human can barely stand? The logistical nightmare. If the precision of the carving didn't break your brain, the logistics of how these boxes got into their current positions certainly will. We aren't just talking about moving heavy objects across an open field. We are talking about a subterranean jigsaw puzzle where the pieces weigh 100 tons and the hallway is barely wider than the piece itself. When you walk through the Serapium today, you're walking through narrow, limestone-cut corridors. These tunnels were not designed for comfort. They were designed to house 24 massive granite sarcophagi. But there is a glaring physical problem: the clearance gap. In many parts of the Serapeum, the gap between the granite box and the tunnel walls is less than 6 inches. Think about that from a labor perspective. To move a 100-ton object, the equivalent of about 60 mid-sized SUVs stacked together, you need a massive amount of input force. In the ancient world, that meant humans, lots of them. Standard archaeological theories suggest a system of rollers, ropes, and hundreds of men pulling in unison. However, the math of the tunnel won't allow for it. You physically cannot fit enough men around the box to pull or push it. If you have only a few inches of clearance on either side, where do the workers stand? Where do the thick, heavy ropes go? Even if you suggest they used a pulley system, you run into the anchor point problem. To pull 100 tons, you need an anchor that can withstand 100 tons of tension without ripping out of the walls. The tunnels are made of relatively soft limestone, not solid bedrock. Any winch or pulley system anchored into that limestone would likely have crumbled under the sheer force required to move the granite behemoths. Then there's the floor. The ground in these tunnels isn't paved with modern steel or industrial concrete. It's uneven stone and sand. Rollers, usually wooden logs, would have been crushed into toothpicks under the weight of 70 tons of granite plus a 30-ton lid. And let's talk about the corners. The Serapium tunnels aren't one straight shot. They have sharp, 90-degree turns. To get one of these boxes around a corner, you would need to rotate it. This requires pivot room. But again, the tunnels are barely wider than the boxes themselves. Imagine trying to turn a king-sized mattress in a hallway that is only an inch wider than the mattress. It's a geometric nightmare. In modern industrial moving, we would use air pallets or heavy-duty hydraulic jacks to float or shimmy the weight in increments of millimeters. The idea that this was done with hemp ropes and raw muscle in a dark, oxygen-deprived tunnel is frankly insulting to the complexity of the task. Then there is the final drop. Most of these boxes sit in recessed pits that are several feet lower than the main tunnel floor. This means that after navigating the narrow halls and the tight corners, the workers then had to lower the 100-ton monolith into a hole with almost zero clearance for levers or jacks. If you drop it too fast, it cracks. If it's slightly tilted, it gets wedged forever. The level of control required to seat these boxes is something we struggle with today using modern cranes. What makes this even more suspicious is the abandoned box. There is one box left in the hallway that never made it to to its final chamber. It sits there like a glitch in the matrix, blocking the path. When you look at it, you realize that once that box was in the tunnel, the workers behind it were trapped. There was no walking around it. The entire operation had to be perfectly choreographed from start to finish, with no room for error, no room for extra lighting, and virtually no room to breathe. The air in these tunnels, even today with electric fans, is thick and heavy. Imagine the oxygen levels with hundreds of laborers and burning torches. It doesn't add up. We are left with a haunting question. Did the Egyptians build the tunnels to fit the boxes, or did they have a way of moving stone that we simply don't understand? If the primitive method of ropes and rollers is physically impossible due to the dimensions of the space, we have to look for a different answer. But if the how is a mystery, the who is even more confusing, especially when you look at the official story of what or who was supposed to be inside these boxes, the sacred bull narrative. If you ask a traditional Egyptologist what these boxes are for, they won't hesitate. They are sarcophagi for the Apis bulls. In ancient Egyptian mythology, the Apis bull was a celestial deity, a symbol of strength and fertility and the physical manifestation of the god Ptah. When a sacred bull died, it was supposedly mummified with the pomp and circumstance of a pharaoh and laid to rest in the Serapeum. It's a neat, tidy explanation that fits the religious context of the time, but there's a massive 100-ton problem with this story. When the French Egyptologist Auguste Mariette first blasted his way into the Serapium in 1851 using gunpowder, he found that nearly every single box was empty. Now, mainstream history argues that grave robbers got there first. They suggest that over the millennia, looters braved the dark, broke the seals, and hauled out the mummified bulls to find gold or jewels hidden in the wrappings. But there's a flaw in that logic. To move the lid of one of these boxes, even just to crack it open, requires massive leverage. Why would a looter go through the Herculean effort of sliding a 30-ton lid just to steal a bull mummy that has very little black market value? Even more baffling is the sealed box. Mariette found one box that was still perfectly intact, its lid still cemented in place. He used explosives to break inside, expecting the find of the century. Instead of a glorious gold-covered bull mummy, he found nothing, just some ritual debris and empty space. This raises a massive red flag. If the boxes were meant to be coffins, where are the bodies? Some researchers point out that the few fragments of bone found in the tunnels weren't even from whole bulls. They were a mush of bone fragments, suggesting a ritualistic burial of parts rather than whole animals. But does that really justify the creation of a 70-ton granite vault polished to aerospace tolerances? It's like building a nuclear-grade safe to store a half-eaten sandwich. Then we have the issue of the inscriptions. Most of the boxes in the Serapeum are completely blank, smooth, polished, and devoid of any writing. Only a few have hieroglyphs, and quite frankly, they look like graffiti compared to the boxes themselves. The carvings are shallow, shaky, and lack the geometric precision of the monoliths they are written on. It's a quality mismatch. It looks as if a later civilization found these incredible chests, had no idea how they were made, and scratched their own names onto them with primitive tools. This suggests the boxes might be much, much older than the dynasty that claimed them. If the sacred bull theory is just a cover story or a later reuse of the site, then we have to face the uncomfortable truth. We are looking at 24 high-precision, heat-resistant, vibration-dampening containers that were placed here for a reason we still haven't figured out. And that leads us to the most heated debate in archaeology. Were these boxes carved by hand, or are we looking at the remnants of a lost industrial-grade technology, lost tech versus hard labor? This is where the debate gets heated. On one side, you have the traditionalist view, the chisel and sweat school of thought. They argue that if you give 1,000 workers enough copper saws, sand as an abrasive, and a few centuries, they could eventually carve anything. On the other side, you have engineers and machinists who look at the granite and say, not a chance. The central problem is the material itself. Granite isn't just hard, it's composed of quartz, which is a 7 on the Mohs scale. Copper is a 3. Trying to cut granite with a copper saw is like trying to cut a steak with a wet noodle. Mainstream archaeology suggests the Egyptians used a slurry of sand and water to help the copper saws grind through the stone. In theory, the sand does the cutting, and the copper just holds it in place. While this works for flat cuts, it doesn't explain the internal corners or the perfectly flat vertical surfaces. If you were using a handheld copper saw and loose sand, you would inevitably see wobble marks. The blade would flex, the sand would distribute unevenly, and the surface would look wavy. But when you examine these boxes, there is no wobble. The surfaces are as straight as a laser beam. Even more shocking are the tool marks found on some of the granite. In various Egyptian sites, including the area around the Serapeum, there are stones that show what look like feed rates. When a modern machine cuts through stone, it leaves a spiral or a groove that indicates how deep the blade sinks with every rotation. Some of the core drills found in Egypt show a feed rate into granite that is 500 times faster than a modern diamond-tipped drill. This implies that whatever was cutting this stone was doing so with incredible force and speed, energy that a human arm simply cannot generate. Then there is the circular saw evidence. On some of the granite lids, you can see faint, curved striations. These aren't the back-and-forth marks of a handsaw. They are the consistent radial marks of a massive circular blade. To drive a blade large enough to cut a granite box of this size, you would need a power source. You'd need an engine. And that's the forbidden word in Egyptology. To suggest the ancient Egyptians had electricity or engines is considered heresy, yet the physical evidence on the stone doesn't lie. We also have to talk about the overcut. In some of the internal corners of the Serapeum boxes, you can see where the tool went just a fraction of an inch too far into the wall before stopping. These overcuts are perfectly straight and consistent. If you were using a hammer and chisel, you'd stop when you reached the corner. An overcut is a classic sign of a machine-driven blade that hasn't been calibrated correctly. It's a mechanical error, not a human error. The gap between what we are told the ancients had, copper, wood, and rope, and what we see in the stone, precision, parallelism, and high-speed cutting, is becoming a canyon that traditional history can't bridge. If they didn't have power tools, then they had a method of softening stone or manipulating matter that makes our current technology look primitive, the resonance theory. If the Serapeum boxes weren't coffins, what were they? Some researchers, looking at the granite's high quartz content, suggest a far more electrifying purpose: acoustic resonance. Quartz is piezoelectric, meaning it can convert physical pressure or vibrations into electrical energy. If you place a massive, precision-engineered granite box into a limestone tunnel, which acts as an insulator, and subject it to specific frequencies, you don't have a tomb, you have a power plant. Proponents of this theory argue that the boxes were tuned to the Earth's own frequency or the vibrations of the Nile. The insane 90-degree precision and mirror-flat surfaces wouldn't be for the aesthetics. They would be for reflecting sound waves with zero loss of energy. These weren't boxes, they were vibrating chambers designed to harness the heartbeat of the planet. While this sounds like science fiction, it's the only theory that explains why the builders cared more about the interior specs than the exterior decorations. Today, the Serapeum stands as a silent challenge to our understanding of the past. We can't replicate these boxes easily with modern tools, and we certainly can't explain how they were moved. Whether they were the resting places of sacred bulls or the components of an ancient energy grid, they prove one thing: the people of the Nile possessed a level of mastery over stone that we are only just beginning to decode. The mystery of the Serapeum isn't just about what's inside the boxes. It's about the impossible hands that built them. What's your wildest guess? What's inside those boxes? Leave your comments down below and consider subscribing to the channel if you haven't.